Did you know that math and music are deeply intertwined? They are like two sides of the same coin, enriching each other. From scales to rhythms, every note we hear has a mathematical foundation. For example, the Fibonacci sequence can be found in many compositions. Consider the harmonic ratios that define musical intervals. These ratios create the beautiful sounds we recognize in music. And let's not forget time signatures. They dictate the rhythm, influencing how we feel the music. So, as you listen to your favorite songs, remember this connection. Let the harmony of math and music inspire your own journey. Welcome to Harmonics and Equations. Did you know that music and mathematics are deeply intertwined? Numbers shape the very fabric of sound. In this module, we will explore the mathematical ratios that create harmony. These ratios form the foundation for musical scales used in compositions across cultures. For instance, the interval of an octave is a 2-to-1 ratio. Let's consider the major and minor scales. These scales are constructed using specific sequences of whole and half steps. The major scale follows a pattern of whole, whole, half, whole, 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 half. Did you know that the Pythagorean tuning system uses simple ratios? For example, the perfect fifth is a 3-to-2 ratio, creating a pleasing sound. This mathematical approach to tuning has influenced music for centuries. Now, let's make this interactive. Adjust the ratios in our scale builder to create different musical scales. Listen to how these changes impact harmony and enrich your understanding of music. Have you ever wondered how sound is created? The physics of sound is a symphony of mathematical principles. From the vibrations of a guitar string to the resonance in a concert hall, acoustics and harmonics shape our auditory experience. Did you know that sound waves travel in a pattern of compressions and rarefactions? This is how we perceive different pitches and tones. Take a moment to think about a piano. Each key produces a unique frequency, creating a harmonious blend of sounds when played together. Graphs show us the relationship between frequency, wavelength, and amplitude. These elements are crucial in understanding how instruments produce harmonic overtones. Now, imagine you could adjust variables like string tension or air column length. In our interactive sound lab, you can see how these changes affect harmonics and frequencies. Did you know that mathematics fuels creativity in modern music? Algorithmic composition blends logic and artistry in fascinating ways. Using rules and patterns, composers can create complex and evocative pieces. Research from MIT shows how algorithms can generate unique melodies. For instance, consider the difference between human-composed and algorithm-generated music. Side-by-side comparisons reveal the unique qualities of each approach. Algorithms can expand the boundaries of musical possibilities. They can analyze patterns, create variations, and even mimic styles. So, you ready to explore this exciting world? Join me in the composition sandbox and generate your own melodies using algorithms. Let's see what you can create. Rhythm is the heartbeat of music. It's driven by mathematical principles that govern how we perceive sound. Time signatures are essential in music. They tell us how many beats are in a measure and what note value gets the beat. For example, 4/4 is the most common time signature, used in countless songs. But what about complex rhythms? Polyrhythms combine two or more contrasting rhythms played simultaneously. They create a rich tapestry of sound, adding depth and excitement to music. Did you know that different cultures have unique approaches to rhythm? For instance, African drumming often employs complex polyrhythms that are deeply rooted in tradition. These rhythms are not just musical, they tell stories and convey emotions. Now, let's dive into the interactive element. Use the virtual drum machine to create your own polyrhythms. Adjust the time signatures and layer beats to see how math shapes rhythm.